Hi everyone, and welcome to the first webinar in 12D's new training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. While we wait for everyone to finish joining, I'll just pop up a polling question. You'll have about 30 seconds to answer about whether you use design speed tables or modifiers, and then I'll show the results. Okay, looks like we've got a lot of people using modifiers or a combination, so I think we'll all get a lot out of today's webinar. Okay, let's get started. Our 12D training webinars will showcase common industry challenges and take a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We also run regular training courses all around Australia and New Zealand. See our website for more details on these, or indicate in your post-webinar survey that you'd like to be contacted about this or in-house training. We'll be running these webinars regularly and recording them for posting on our website and on YouTube. Our first 5 webinars from our Industry Solutions series are already available online if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout this webinar. At the end, I'll also read out some of the questions to the presenter for his insights. Today's webinar on utilising design speed tables will be presented by Peter Taynton, who has over 20 years' experience in various facets of road design. He has been engaged in large projects for several major councils and government road authorities. Over the last 15 years, he has worked closely with our programmers in the implementation of a variety of design features within 12D model. These include the superalignment and design speed tables, construction subgrade detailing, design geometry components, overlays, pad design interface, and visualization. This training webinar will address the challenge of designs that involve the application of superelevation and widening, the time-consuming calculations and recalculations when designs change, and the issue of conforming to the standards of road authorities during this process. To achieve these aims, we will look at design speed tables in 12D model. Over to you, Peter.
Thank you very much, Lisa. Welcome everybody to our presentation. Today's training overview will involve the discussion and explanation of design standards. Normally that would be referred to as design speed tables. The incorporation of these standards in our design template. So inside that design template and the standards, we're going to look at the horizontal curve super, the rotation of the super, and the super elevation development. In the vertical, we'll have K values for crests and sags, and also curve widening. And finally, applying those design standards via your super alignment and MTF. We'll also look at design speed overrides and customization. In other words, we're able to achieve variable speed design. We can do manual override of all parameters, super elevation value, the runoff length, and the positioning of the runoff length, road widening, and also options to ignore the super and widening for a curve totally. We'll look at design standards, parameters versus string parameters where they are different. And finally, hinge widening treatment via the MTF file. Designs that involve the application of super elevation and widening can involve numerous calculations. Design manuals need to be referenced and values extracted via formula or standard tables. Shown here are several extracts from a design manual. Diagrams explain the terms of the application of super elevation, along with references to tables and formula. 12D design tables are easy to use and have the ability to be customized to suit your particular region. The design table or template is linked to your design centerline or super alignment. The super alignment can be profiled in the section view in order to display not only the vertical geometry, but the super elevation and the widening. Once satisfied with the design parameters, they can be automatically applied to your design. If you look at this example from the manual, we're looking at the rate of rotations to see the combinations here. We've got a minimum value. We can also have differing rate of rotations for particular speeds and a formula involved. And the table here for the development length and different speeds and crossfalls. This diagram here is showing the terminologies. So here we have SRO, which is the super elevation runoff length, and that is a distance from zero crossfall to maximum super, and the which we enter in our design speed tables. And this one here is calculated by 12D. This is the tangent runoff from the normal row crossfall to the level position. And again, there's terminologies of the actual runoff. This is a transitional spiral, so the runoff is applied over that transition, and both combined relate to the superelevation development. So look at our design speed tables inside 12D. They're under design superalignments, and we'll pin that panel. So look at our design standards. So again, this is a example file. There's one for urban, rural, and so forth. So they are a example sheet with 12D for you as a start position. There are some defaults, so each panel can have a default. It's under urban here. We're looking at our normal row crossfall. And again, this is was set to -3%. So that's the crossfall on the straights. Maximum superelevation for this particular urban row is 5%. The development on curve ratio, so that's set at 0.5, which is equivalent to 50%. This relates to the positioning of the superelevation runoff for untransitioned curves, so that means it'll be 50% either side of the tangent. We have a default speed, so when you do set this for your alignment string, you do get something come up. Those values can obviously be changed. Same goes for the default lanes. There is an ease-off value, so that there would be for the method of transitioning at abrupt changes of superelevation. So we drop down to the 70K environment here, and again, each one of these has some defaults at top and a tabulation displaying information about that particular speed. In this case here, we're looking at the rotation, relative grove force, so got a reverse length and broken back length. So the broken length varies a bit from speed to speed, but to have a look at those and explain what they are, we'll just go down to a diagram. So this is the reverse situation for transitions, curves without transitions and curve width. So if we can maintain this value that's 30 meters at the regular crossfall between the two curves, then we will develop the super down and then the super back up for each curve. If the curves are getting closer together and they're reverse curves and we can't maintain this distance, then we'll rotate the superelevation like that. So again, you'll see the same for the curves with transitions. For broken back or compound curves, we have the same scenario. A distance is calculated via a formula, and if we can maintain that distance, then we will rotate the superelevation down to the super or the crossfall on the adjoining roads. If not, we'll then send through the crossfall here, so we have a one-way crossfall matching the two curves. So back inside our table, we've now dropped down to these. So these are all individual ones for each particular speed. So the radius columns, we're more interested in the minimum radius, obviously, but there also is an arbitrary maximum radii. So we look at the rate. The rate is the superelevation for that particular radius value. And we also look at the runoff value. Again, that's the distance from 0 to maximum super, and applied 50-50 either side of the tangent points or over the transition. We do have a ratio option. You can enter that and have a particular ratio for the development of the runoff for one particular curve, but most times we just default to the one up here, which is the 50%. There's a option for yes, no, in whether you're going to use a transition, and obviously a minimum length for the curve. So in those examples, there's urban road and a rural road and so forth. There's also a road widening option for the horizontal. This is a horizontal tab. So in the road widening, we've got a single unit truck, prime mover, B doubles. As long as a prime mover, we've got a lane width, 3.5, and then under here we've got a list of the widening that suits a particular radius, and that drops out after 300. All these panels can be copied and pasted. There's options up here. If you like what we've got here, you can copy it, rename it, and then change it to what you would like. So we've got a crest standard for the vertical. So again, we've got 2-second reaction time. It's been calculated for the minimum K value and an arbitrary maximum K value. And again, on here there are also defaults for the vertical. So this is a SAG standard for a 2-second reaction time, and again, similar to the crest. So once you've set up your design standards, and you then need to draw those all together and pick which part suits your road design. So that's part of the design template. So again, we have some examples here. So for the urban road, I picked up the design speed table for urban. I put in a few defaults and also picked up the widening table that I wish to use. The same for the vertical. I picked up the crest table and the sag table. And then I've got several ones, and these are the names that come up when you create your alignment string and select your design standard. So we go and create our alignment string. Besides our normal options for name, color, and so forth, we can drop down to label, and we'll select a label for our job. We are going to use a design speed table. So obviously we're going to use IP method in this situation. So we need to say that if we're laying down the IPs, we want to use curve speed. By doing this, the design speed table is specified under the advanced tab. So again, we select the use design standard, and we'll grab our rural road. This is the default that comes up that I talked about before, so we're happy enough with that. So as we lay down the IP, as I said before, it's going to generate a curve for me in my corridor. So I want to put down the minimum horizontal and the minimum maximum. There also is an option to look up here if you pick a speed or a radius that's in between two in the table, so we can do a round up and round up. So I append my horizontal geometry. I'm just going to use my cursor snap here. So as I pick my second IP, it then starts to address the speed table and to try and put in the best fit curve that it can for this geometry. Again, I pick my third and my fourth. So this ability here is only available with the IP design. So if I look at my curves, it's now positioned to put in a 187 curve with a transitions for me. And down here, I've just got simple untransitioned curves. So that's by setting the minimum. This is the minimum curve that can fit in this arrangement. So I now go and profile my alignment string. We have no vertical at this stage, but down the bottom is our corridors for the superelevation. It's set at RL0. So if I zoom in here and I use the little height option for my cross section, which is reflected down here, I can hover over this and I can see that reflects 5%. That's the left super, the right super, and this string here is the widening. So we zoom out a little bit further, there's another string up here, a brown string, which is the speed profile. So again, if I zoom in and position my cursor, it gives me a quick answer there that is set to 70. So again, if I now look at the reverse curve options and the broken back curve that I showed before on the diagram, it's a little bit easier to demonstrate live here. So I go move, and I move this IP. As I move the IP closer to IP number 2, you'll see in my section view that the rotation of super now obeys that reverse minimum 30 meters that I talked about before. If I now move back towards the other curve, which is the broken back curve, you'll see in the section view that the super elevation now reflects in a one-way crossbore. That's just a live demonstration of what I talked about in that panel. So again, with the IP method, it has put in a values for you. So we're looking at the first of an override for this particular job. We can go to our element part. And we drop down to the IP speed here. Now for the IP speed options, we are able to do a direct override here. So I can put in here 80 Ks and go set, and it will automatically then adjust and search the design speed table and put in the value for the minimum radius that it can fit, and also displays the new super elevation. And here we look at the speed profile is now up to 80. So this is unique only for the IP. So I set that back to the original string profile. If I now change the type of IP that I have, in this case here I have a IP radius. So once I select the IP radius, it's the onus of the designer now to enter values that are adequate for that particular speed, whether or not there's transitions involved and so forth. This would be a similar situation if you're doing element design. In that case, using fixed, free, or floating curves and transitions. So then it is then up to the designers that automatically lays these down is the IP method. But the super elevation and the widening is taken from the design speed table for that particular radius. Here's a link back to the design table, so you don't have to keep on going to the design standards, opening it up and trying to check what the minimum radius may have been for this particular speed. So any radius option in the element part or IP, you can go left button and you'll get a direct link back to the design speed table. So if you did put in, for instance, 154, and then you went a little bit lower than that, and you unset, then you would end up with an error. No super elevation would be shown or displayed here because that value is not in the design speed table. So again, it's a good little check to have. Right, so at that stage there, that's the only type of override that we have, unless we go into the edit options, and we'll show that in the next alignment string. So again, for the vertical geometry, it's a similar situation that we did before. We're putting in our IP, and then again, it's automatically reading the design speed table, checking for the particular curve it has for crests and sags, and again, placing in the vertical. So if we look at our design that we've already produced before, this one's an element design. So if I profile that, you see it's already got a design speed table attached to it. And again, at this situation here, you are in the element design mode, so it's not automatically putting down a radii for you. The design has done this. So we put a combination of fixed straights and free arcs. So the only connection we have back to the design speed is through this little corridor here. If we go to part number 4, so part number 4 is a 300 curve there, and we've in our design we've decided that's what we want. So now we want to be able to customize the super elevation and possibly the widening for that particular curve. So this is the link to the customization, little icon here, edit custom. There's an automatic pan option here. We'll just turn that off so we don't jump around everywhere. And there's an option to insert segment. As you see, it's only doing custom, super elevation and widening. It's not changing radii or anything. So I go and select the curve. The choices I have to customize the 300 curve here in relation to the super elevation and widening is I can do speed, I can do manual, or I can ignore. So in this case here, if I do speed, I can type in 80, go set, and it will then address the design speed table, put in the required super elevation for the 80k speed, and you'll see a change in my profile here. That's one option of doing it. We can also go ignore. So we go ignore, it just simply ignores the super elevation and widening for that curve. Probably not a good idea for this particular road, but for large radius curves where you don't require super elevation, you can then simply just set that to ignore. The other option is manual. So in that case here, if I set that just back to speed, obviously it'll drop back to my original string speed, and if I go to manual. So the manual option here allows me to override all this information, the inside super, the outside, so I can simply change that to -5, outside 5, and I can go set. So again, it's now at this particular option. So I can change any or all of these options here. If sometimes you're not too sure, you can actually type in a speed example of 80 and press enter, and it will then automatically fill out everything that you need. You can make your mind up which ones that you want to change. Having these options here, and then in your design process and not being too sure if you want to use them or not, there is an option here to say active or not. So I set that back. It's still there for you to turn back on if you want. Besides the customization to curves, we can also do a customization to the straights. In that case here, there's less choices. There's only left super and right super, so I'm looking at this option, this straight here between there. I now want to produce that crossfall through at the one-way crossfall, so I type in here 3% and go set. So you have the customization options there. If I go back to the part editor, we'll notice that on our parts, anything that has a small little character, like a little caret at the end of there, has been set up as a customization. So again, if I picked on that and I go straight back, it'll take me back to the part. Sometimes if you're looking at your job and you have a string like this, so it's only a simple one, has a design speed table attached to it, and it's obeying the design speed tables. So we're looking at a radius of 40 meter transition. So in our plan view, I've decided in the process of my design that I want to change the plan transition to something other than what's in the design standard. So I change that to 60. I go set. So you'll see that the rotation of the super here is over to 60 meters, which is a transition there, which is fine. But then I may then want to be able to say, well, that's okay for my plan presentation, but I want my super to rotate over the original standard. So that's also a customization. So I go to edit custom. Again, I pick the curve. So inside here we have a approach transition. What do I want to do there? So the choices is either string or standard. So in this case, at the moment, it's defaulting to string. I want to go back and use the standard 40 meters. So I go set. It now rotates over the 40 meters instead. Another option for the customization then is for things like off-ramps. So in this case here, if I go on profile, the off-ramp, there's no speed tab attached to this, but it is running parallel to my freeway here, so it's got large radius curves here, but then as it gets closer to the roundabout, they're quite small. So in order to set a design speed table for the off-ramp, I drop down to design. I've got to make a choice. So in this case here, I'm going to say it's a rural road. I'm going to start with the approach, which is 100 Ks. I go set. So these curves are obviously in the design speed table because there's something shown, but as I get off the ramp, these radius curves are quite small, so they're obviously not going to be in the design one. So I need to customize them. I can bring up the parts like I did before, but there is a shortcut here that takes you down to the custom editor. And again, if I do the custom editor, pick that curve, I can then say at that particular point, I want to be 80 Ks. So I get set. You'll see it's now produced the crossfall through that curve, and I'm now down to these last two. Similar way I can do before, I pick that curve. In this curve here, I might be interested in dropping down to 60. So I can turn around and change this to manual, type in my 60 curve, and I get some information. Good part about that is you get a lot more information about it rather than trying to guess things. So here I may also not want the widening. So I can take that out. That's set. Let's now produce that. And finally, my last curve, I just wish to match the crossfall on the roundabout. So again, I customize. I drop down to manual, and here I'm just looking at my inside crossfall, my outside, and I'm looking at the approach runoff. I don't really care about where it's ending at the roundabout, and I type in there 20 meters and go set. So that way I'm able to use the customization all the way through, even on a tight curve like that off ramp. So now we've got our road design, and we wish to then be able to apply all that information about the superelevation and widening to our actual road design and then through into our MTF file. So go into our apply, and we'll grab the apply menu manager. This option here will create the MTF file for you with the templates that you specify, and also the apply many option or function. It uses the apply many defaults. You can actually pick more than one string to do. We're just doing one. So we want all our design strings and sections to pop up straight away. So we're just going to do a view for display. We've got a template for the left-hand side, template for the right-hand side, and I go create. So basically what it's done is produced the apply many function for you. So here it's produced the MTF file and done all the hard work for you. So we go to our cross-section view and we zoom in on our first curve here. This is an actual untransitioned curve. If I profile my cross-section, you'll see at this stage here, there's no super elevation being applied, even though the alignment string has a speed table attached to it, or a speed design, there is no super elevation. That's all done inside the MTF file. So again, we bring up the MTF file. It's under the More option. So first off, it's super widening. You need to enable the super widening name, so we tick that on. Then we go back to the left-hand side. We're going to do the left super. You can do, I'm just picking the strings from here, you can actually use wildcards, but I've only got a couple of strings here. So I picked the edge of carriageway and shoulder. Again, under More, there's also a left width. So you are defining which strings you wish to apply the super elevation and the widening to. So for things like the super, if you do actually insert other strings later on, other lane lines, and you wish to then to be super elevated, you just got to come back to here and repick them. And again, under the last one, I select the right width. And I pick the carriageway string. All right, so now, we now have super elevation. We also have the widening, so the two strings that I selected from left and right now have another 0.4, nearly half metre widening added. This is the untransitioned curve. So notice here that the road centre line and the lanes have actually moved. They've all moved to the inside of the curve. So if I add on this model here, it shows you where the old edge of left-hand shoulder or carriageway edge was. So it's still in the same position, but all the other strings have moved inside. So if you do look at this down the bottom, you'll see the actual shift. So all those strings have moved to the inside of the curve. If we go down to the transition curve, and again we'll profile that cross section. You'll notice that there is no shift. The widening has just been applied to either side of the strings that you specified. So back to our first curve for the untransitioned. We can look at the options in relation to the hinge scenario. So in this case here, it's done a horizontal shift. You can see my original alignment string, and you can see where the hinge string and the lane lines have all moved to the inside of the curve. If you want something different here, under the More, there's an option for hinge widening treatment. So at the moment it defaults to horizontal only. So we also have several options. One of the ones is horizontal and vertical. So I say OK on that and recalculate my job. You won't see much difference in plan view, but when I go to my section view, you'll see now that it's actually, here's the center line. It's now done a horizontal shift and a vertical shift. That vertical shift is in relation to this crossfall, and we have that scenario. Also, if you don't want like that scenario, these are all set up for different situations that clients have asked for. So I go to here and I change this to none. And again, recalculate my job. Now you see a difference in the plan view. There is no shift to the inside. If I go back to here, but it still has done the widening that you're after. So for the development of the super and that sort of thing, it's not only appears in your cross-section plots as a normal cross-section profile, we also then have a super alignment plot. So inside here we've got the details for the super elevation. So it's under my long section plot. So it's all set up under the boxes, super elevation and widening. It has several choices over here. I like using the one for cross sections because in the actual design, in the apply mini recalc, it produces cross sections at every change of super and also any crest or sag. So it's a good idea to use the cross sections. In our left side, we just simply select our center line and our carriageway, and the right side we select that too. So then we're able to show up our super elevation in our long section plot. So that ends our presentation. So I'd just like to ask, are there any questions?
Thanks, Peter. Yes, I think we've got time for a couple of the questions that have come through. We've had lots of great ones through today. A few people would like to know, can you overwrite cross-fall values, etc., in the MTF after using the design tables?
Yes, you can. The strings selected are for super and widening are just your strings in your normal design. So modifications can still be made afterwards in the MTF file.
Okay, thank you. Vinay in New Zealand has asked, are the default design standards based on Austroads?
Well, yes, they are, because it only makes sense that the tables are based on some sort of standard and not just made up. So in our case, they are based on Austroads. But as mentioned, it's always the responsibility of the designer to verify any results. The tables obviously can be edited to suit a particular design requirement and also any local authority.
Wonderful. Anthony from Sydney has asked, is widening interpolated for values between those listed in the table?
The values you had there, you mean for if you specify, not too sure of the question, but if you pick a raise something in between those two, it would then obey the actual round up value, so it then goes for that. I don't think it actually has an interpolating value.
Okay.
I'd have to check and get back to you on that one.
Sure, that's fine. Brian in the Gold Coast would like to know, do speed tables only work with IP design and not elements?
No, as I addressed in the presentation, it works with the design speed tables, but only for the information in regard to superelevation and widening. When I lay down the IPs and automatically produce the curves, that's just a peculiarity of our IP design. But every design that you have in your horizontal geometry, if you specify a design speed table, as long as your radii fall into the category of the design table you pick, then you will get superelevation regardless of whether it's IP or element.
Okay, thanks. That's all we've got time for in the live Q&A today. Sorry to those whose questions we couldn't get to during this session, but will be individually afterwards. The recording of this webinar will be available in coming days on our website and our YouTube channel. Our next two training webinars will be Visualization on the 27th of April and Creating Symbols and Line Styles on the 11th of May. We're also continuing our Industry Solutions webinar series from the 14th of April next week, so see our website for details of all of those. We'll keep updating the website with many more topics in coming weeks and also keep you posted through email and social media. And don't forget, we've also got our next 12D International Conference this July with the associated Innovation Awards. The awards closing date is the end of this month, so if you haven't submitted your entry, now's the time. If you need to contact us about anything at all, our details are on the screen now. That concludes our presentation for today. Thank you very much for attending, and we hope to see you at future webinars.